Okay, fine then. So see here, Sabarisha. So when you take a convex lens, what is a convex lens first of all? What is the nature of a convex lens?
Converging lens.
Yeah. So convex lens is a converging lens.
Yes, sir.
That is like when rays pass through a convex lens, when multiple rays pass through a convex lens, they tend to converge or meet at a point.
Okay, sir.
That is a convex lens. So our diagram represents, that is like here we will be trying to position your object. In our question, when an object is placed at different distances from the convex lens, they tend to converge at different position. When an object is over here, it would converge over here. When an object is over here, it will converge somewhere over here. And also not only the converging, it also, the nature of the image also gets altered. Clear?
Okay, so inversion size.
Yeah, whether it will be a real image or a virtual image, or whether it's inverted or erect, converging lens will never give erect image. Okay, I mean the straight image. Clear? It will be always inverted. Okay.
Yeah.
And it will be real or virtual. And what is the size of the image? That is like whether it got magnified, whether it got diminished. All these stuffs we're gonna actually see. For that, we need to actually follow three natures or three rules how an light ray will pass through a convex lens. Okay. Three rules, or we call it as properties. First one is like, assume that we have a convex lens over here. So the important positions in a convex lens. The center of a convex lens, we call it as optical center.
Yeah.
And actually there is, from a convex lens at a particular distance, we have a position called F, which is nothing but focus. It is where the entire light ray gets concentrated. That is like, it is said to be the properties of concentrated. Clear? So that point we call it as focus. So for an optical center, we have focus on either sides. And for better understanding, we will take twice this distance and we'll have another position called 2F, twice the length of focus.
Okay.
Okay. So the first rule is ray parallel to, what is this line called first of all? So I forgot to say that. Principal.
I think I only know
principal axis. Clear?
Here.
Principal axis. Clear?
Yes, sir.
Now ray parallel to principal axis.
Focal.
Oh, sorry. Will pass through what?
The focus.
Yeah.
On the other side of the lens.
Yeah. Assume that a ray which is parallel to the principal axis over here will surely pass through the
focus on the other side.
Okay. It's LE, sorry. So pass through the focus. Now the next one is the opposite of that, or we say it as ulta. That is like ray passing through the focus.
Yeah.
Ray passing through focus will emerge parallel to axis. Clear?
Yeah.
That is like, assume that a ray is actually passing through focus. I'll draw another diagram here. Ray is actually passing through focus. After refraction, it will emerge parallel to the
principal axis. Okay.
Yeah. Now the third law. Ray passing through optical center
will continue without being changed.
Yeah, will be directed in the same path.
Okay.
Will be directed in the same path. You're clear with the three laws, right?
Yes, sir.
Yeah, actually using this three laws only, we are actually going to create the ray diagram itself. Clear?
Okay.
Now I'll reshare the screen because we have another, I have a document. I'll be sharing it in email. You need not copy anything in that, so that you can just understand that alone. Okay, clear? But I'll share you the notes. Clear?
Okay, sir.
Okay. Okay, you could see the screen, right?
Yes, sir.
Actually, we have 7 diagram here. That is like 7 positions how actually the convex lens gets altered. This 7 you study, that's more than enough to crack the question. But mostly in that, you'll be getting the last question, last type alone. Clear? But last step, since it is asked last year itself, there are less chances to ask the same one. Clear? But
yes,
still,
sir.
when you go through the other papers, the repetitions are actually more. So you need not worry regarding that. We will first take the type 3, then we will come back to type 1 and type 2. Okay, let me tell you first of all how to create the ray diagram. Okay, so first of all, you need to create your principal axis. How means? First, draw a horizontal line, fix one position, which is nothing but your optical center C. Then draw a spherical lens around it. This and all you can do it in as a rough sketch. No one will take consider anything regarding that. But when you measure the distance, there actually you have to measure it using the scale properly. For your diagram, you can take 2 centimeter in your notebook. Clear? Take 2
Yes,
centimeter
sir.
from the optical center and mark a point which is nothing but your focus. Now take another 2 centimeter and mark another point which is nothing but a 2f because it's twice the focus, 4 centimeter. Clear? Clear, Sabrish?
Yes, sir.
Okay. The same way on the other side. F, you can always call it as f dash or 2f dash, it doesn't matter. Because in IGCSE, we don't actually use f dash, but still this is the actual notation. Okay. Now, drawing that particular diagram, we'll actually refer this diagram itself and we'll do. Excuse me a minute. So, now, my object is over here. What is this position called? It's beyond 2f, right?
Yeah, beyond 2F.
B of t. When an object is beyond 2f, let's see how your image gets altered.
Okay, sir.
So see here, from this object, when a person actually stands in front of a mirror or lens, he will actually send out multiple rays. Can you understand? Infinite amount of rays will come out actually. That is the fact. When a person sends light rays out of an object, he actually sends out multiple rays. But we cannot actually draw multiple rays, right? That's why what we do is like, we will assume 2 rays coming out from that object. Clear? So I am assuming 2 rays. So this 2 rays I will be drawing in such a way that it will be based on the 3 laws. Any 3 laws you can use. Clear? Any of the 3 laws, any 2 out of 3 laws, sorry. Any 2 out of 3 laws you am using. So I am using the first law now. Ray parallel to this axis will pass through what?
Focal one. F
Focus
dash.
of the concave mirror. So one ray has passed through like this. Clear?
Okay.
Now I'm going to use the second law. What is the second law? Ray passing through focus
will emerge out parallel.
Will emerge parallel to that. Okay. Now these 2 rays have met at a point. Now draw an arrow mark towards that point.
Okay, sir.
Clear? This is your image formation. When you actually measure it properly, 1 centimeter, 1 centimeter, and if you draw means you will actually get it like this. This is actually properly measured, my diagram. Clear?
Okay. Okay, sir.
But this is how you'll draw. You understand how to draw, right?
Yes, sir.
Okay. Now, when 2 rays met means that coincidence indicate that that image is real. If you find your rays getting coincide, they real. Clear?
Okay, sir.
Now, position of object. It was actually beyond 2f, but your image was between f and 2f. Clear?
Yes, sir.
And nature. Nature, you will tell 2 things. Whether it is real or inverted, you will check. sorry, real or virtual, you will check. Whether it is erect or inverted, you will check in nature.
Okay.
So obviously they are coinciding, so it's a real image, and you can see that it is inverted, ulta, so it is inverted. And size of the image, you can see that now here you cannot see because I took a approximate measurement, but when you measure and see, the size is comparatively
diminished.
small.
Yes, sir.
Small, na? So small means diminished.
Okay,
So
sir.
these are the 4 things you will actually see in a ray diagram. Clear?
Yes, sir.
Yeah. So this is your first type. Moving with the next one.
Okay, sir.
Now here you can see that the position of an object is at 2f. The same way,
Yes,
here
sir.
they are using law 3, law 1, and law 3. Ray parallel to axis passes through focus, and ray passing the center of curvature will emerge at the same direction. Now, here,
Okay,
this
sir.
is actually one of the famous MCQ question. Mostly, this type of question will actually come in MCQ. That is like they will show this diagram, and actually they will ask the image is at object is at 2f, where you will get the image. It will also come in 2f only. Yeah, because we got it at 2f. Clear?
Okay, sir.
Yeah. Why they give it in MCQ means because you will not get more time to draw and check it out. So under the case, this question you need to actually it will be better if you memorize. That is like 2f means you will get the image and 2f only. It saves your time.
Okay.
And also the image size also will be same size only. You measure and see, you get the same. You will find it to be same.
Okay.
And nature, obviously, they are coinciding, so it is real and it is inverted. Clear? We'll move the next
Yes,
one.
sir.
Yeah. Now here, what is the object position? It's between f and 2f.
Between f and 12.
Yeah, and the same law 1. They are actually using law. Law 1 and law 3. Law 3.
Oh, this is 3. Okay.
Yeah,
sir.
but if you use 2 also, it will come. That doesn't matter. Clear? If you use 2 also, you'll
Yes,
actually
sir.
get
Okay.
it. So now,
So,
position of image, it is beyond 2f, and they are coinciding. So real, it is ulta, so inverted, and you can say the size is actually bigger, so it is enlarged. Clear?
yes, sir. Okay.
Yeah. So this one is actually a bit different, this type. So when an object is at focus, you cannot use one law here. Which law you cannot use here? You can use only 2 laws here. You cannot use one law among the 3.
Because
Second law you
on the
cannot
focus,
use.
you cannot use the second law.
Yeah, already it is at focus. In how you can find the ray passing through a focus? Obviously not, right? So under that case,
Yes.
I am forced to use first law and third law. But other things under you can use any law actually. So ray parallel to axis will pass through focus, and ray passing center curvature will emerge in the same path. So here what you can see about this diagram, how the rays are going.
They're parallel.
Yeah, parallel means it doesn't mean they will never meet.
Maybe they'll meet at some point.
It's not like maybe they'll meet. You can never assume they doesn't meet. They will surely meet. Okay. But meeting at a infinity. Infinity means they are meeting at a somewhere larger distance where you cannot calculate.
Okay.
And also they are not parallel. They are 99% parallel, such that you cannot identify that one person converging towards each other. So that converging is very, very, very small, that they will meet surely, but somewhere at infinity they'll meet. Clear? So obviously they are at f, and the position of image somewhere at infinity they are meeting. So at infinity. Parallel means this infinity. Clear? But yes, I told you, right? They will surely meet. That's why they are real. And obviously it will come somewhere at infinity inverted. So it is not large. It's very, very large.
So but parallel.
I told you that 99% parallel.
Okay.
That is like here when you take this image, assume this image. When you check through this point, they will appear to be correct. Here only you will find it that they are not parallel. We are actually in this beginning stage because they are converging slowly 1%. Not even 1%, 99.9%, 0.1%, it's actually converging. So you can never identify at the beginning stage. So in a smaller size image where we constructed, they will appear to be parallel. Clear?
Okay, sir.
Okay, fine then. Yeah, because if you consider parallel means how they will meet. Parallel lines never meet, right?
Yes, sir.
Yeah, because they are 99.9% parallel. So they are highly enlarged. That image will surely be highly enlarged because they are meeting somewhere at the larger distance. Clear?
Yes, sir.
Yeah.
Okay.
So moving to the next one. So this is the important question you need to actually consider. Very, very important question, because many times in the question, this type only got repeated. The other questions hardly came in either in MCQ or theory, but this question maximum times came in your theory paper. So here, this is your object. So object is between focus and optical center. Now, so here we are using law 1 and law 3 because we cannot use law 2 because it's behind focus. So we cannot use law 2. So ray parallel to axis will pass through focus, and ray passing through center of gravity emergency. So what can you say about this nature?
Virtual image.
They are diverging, correct?
Yeah, they're diverging.
At least in the previous image, they were tend to be 99.9% parallel. So we had a possibility they will meet. Do you think that a diverging ray will meet? Obviously not, right? No. They will never meet. So what I am assuming that they are not forming on the other side of the lens. I am imagining that the ray is actually forming somewhere behind in the same side of the lens, somewhere behind. So I am making the two rays join on the same side of the mirror such that they meet at a point.
Okay.
Clear? Now, this image is considered to be virtual because they never met over here. We tend to imagine on the other side and we met. So obviously it is virtual. Clear?
Yes, sir.
That's what. So you got it that position of image on same side of lens, F and 2H. And nature of image was virtual and erect. Size of the image was obviously it looks a bit larger, enlarged. Clear?
Enlarged, virtual, okay, and it's erect.
Yeah, it's erect because it's not inverted.
All the virtual images formed by convex lens will be erect.
No, all will be inverted. You're
no,
saying
virtual image.
Yeah. Virtual image will be erect actually. Yeah, because they are forming on the same side of the lens, right? That's fine. Clear?
Yes, sir. Okay.
But this is the only position you'll get virtual image when it is between F and C. Clear?
Okay, sir.
Yeah. Now we'll come to the first and two positions actually.
Okay, sir.
Actually, we actually saw some types of images or types of rays which actually produced images at infinity, correct?
Yes, sir.
But what if your object is at infinity? Assume that the object itself is coming at infinity.
Okay, sir.
Okay. Under that case, what will happen is like we will be having two possibilities. Assume that when an object is coming from infinity, there can be two possibilities. Either the object will be in single plane, that is, it will be completely up or completely down, or either the object can be between the plane. Can you understand?
Yes, sir.
Like this, between on single plane, either it will be up, either it will be down. When an object is between the planes, like this, you have to take two rays, one ray on each plane. So I'm taking one ray from this plane and one ray from this plane. So for both the planes, I'm forced to actually take one law, first law. Ray parallel to axis will pass through focus. Ray parallel to axis will pass through focus. So obviously they are producing an image at focus. Can you understand? Still it will be called as inverted. Clear? Still it's a real image which will be considered inverted. Clear?
Why we can't? Okay.
That is like, assume that you actually created one image practically like that. When you check through your microscope, still you'll find that the image was inverted.
Okay, sir.
Clear? it was found to be inverted, so we actually consider it like that. Clear?
Okay,
And
sir.
it's real image because they are coinciding and they are obviously highly diminished, very, very small.
Okay, sir.
Okay. Now, coming to the position of another one, that is like type 1. When object is at infinity, but on one side of the plane. So another case, assume that I am having an image on one side of the plane. So two rays are considered to be coming from the same side. Clear?
Okay, sir.
So another case, I'm taking law 3 and law 2. Ray passing through focus emerge parallel and ray passing through center of curvature will be directed and you get it on F, but little bit diminished and real and inverted. Clear?
Okay, sir.
What actually can you infer from this diagram? One thing you find it similar. What is that? That is one of your MCQ question.
Similar to what, sir?
In two types you saw now in object at infinity. What did you find actually? One answer will be same in both the cases. Not it's a real image. Not about the real. Another one answer. Both wherever the
Both
object,
are formed at focus F.
yeah, wherever may be the object. That is like it can be from one side of the plane or other side of the plane, but at infinity or between both the sides, they will surely meet at F only. Clear?
Okay, sir.
Okay.
Anywhere beyond 2F or only at infinity they'll meet at focus?
They will meet only at focus, but the sizes may differ.
Okay, sir.
Clear? You got my
So,
point, right?
like if I have an image, some random image at some distance from
Don't say
like,
image,
beyond
object.
2F.
No, don't say image,
Okay,
object.
an object. Yeah.
Yeah,
Object
you have an
beyond
object.
2F. Yeah.
Yeah,
Beyond 2F.
infinity means beyond
Will it
2F only,
surely
right?
not infinity, just beyond 2F.
Beyond 2F, yeah.
But I know the distance. Will it meet at F or is it not possible to predict where it will?
Beyond 2F means we have the type, right? Just now we saw now. Beyond 2F means you will find it between F and 2F.
Yeah. If it is at infinity, it will be F. Okay. Okay.
Yeah, infinity means somewhere very far away from 2F. Clear? For that, you cannot just say like keeping an image like this. And if you say this is beyond 2F means that can be less accepted because this is also somewhere far away from 2F, right?
Yeah.
So there might be chances this will meet at F. Clear?
Okay, sir.
Okay, fine then.